the video will be start. Hopefully. Okay, welcome to my hydrology course, CE 323. You see the lecture as I'm right. You are see the lecture, cover lecture. In this lecture, we are going to talk about the introduction to the course and topics that we will cover in this course. And also we will start the first chapter of our textbook. Let's get familiar. Yep. Okay, what we are going to study. This is our textbook, Concise Hydrology, and written by Daviahan. It is free for download. If you had my fluid mechanics course, I already said that this is only a concise book. It gives us headlines that we have to study, and there are some other references. As you see, for more and detailed studying, you can go through the other references like educational movies, YouTube videos. Applied Hydrology of Ventica is the reference book entire world for civil engineer. For civil engineers, Applied Hydrology of Ventica, published in 60 years ago. From early 16, and published by, this is 60 years ago. Now we are in 2020. And the book was published first in 1960, so 60 years ago. McGraw-Hill and some other references we have, but I will try to cover most important things of the book with extra or additional information in my lectures. Then I will upload the lectures on LMS every session, before session or after session. It depends if it is ready or not. Sometimes always, this is my character. I never teach repeated lectures. I always add new things, improve my previous lectures each semester. So the updated one will be added on LMS. You can download it, PDF format of my presentation, and study and go more details to find more details in different books. So the book covers several chapters, and we will try to maybe cover 70 or 80% of entire book. Every session we will have different or complementary subjects. Today, our first week, we will talk about introduction to the course as we have now, then hydrologic cycle, then water balance. I will cover the water balance today also. Therefore, in that way, we can compensate the session that we lost last week because of extending the enrollment. You know that I postponed the first session to this session. Therefore, today I will teach two lectures. Lecture 1, shortly introduction to the course, and lecture 2, water balance. Then also catchment. Catchment also will be talked maybe can be talked today. I'm not sure about it, but let's continue. Then we will talk about some hydrological components like precipitation, rainfall, evaporation, evapotranspiration, infiltration, groundwater. These are up to groundwater section or lecture 10 are all components of hydrological cycle. You already know about it. And in the last 4 sessions, we will talk about hydrographs, unit hydrograph, and hydrological measurement, and also statistic of hydrology. The course as grading system, as you see, is the 40% for midterm exam and 60% for final exam. Additionally, you will have some activities activities, not as a homework. You see, there is no homework score, but you will have activities to get extra bonus. And you encouraged to do all activities. It will help you to improve your GPA also. Okay, now some basic questions. Basic questions from you. Do you know what is the meaning of hydrology? Do you have any opinion, any idea? Okay, so let's, I don't write, Celine. Try, if you are going to write, no, don't write. Just speak and communicate in my lecture as high as you can. And no need to raise your hand. You can stop me and start to talk. I welcome any question during my lecture also. So let's ask Erdem. I have one Erdem. Erdem Kantar, please open your microphone and talk about anything you know about definition of hydrology. Do you know what's the hydrology mean? Do you have any beforehand knowledge about hydrology? Erdem Kantar is not in the class maybe, but he seems online. Okay, let's continue with Selin. Selin, do you have any opinion about hydrology?
No, I don't.
Akif, how about you?
I guess water circulation.
Water?
Circulation.
Circulation of water. Where? Circulation of water where? On the Earth, entire globe. Yes, that's a kind of hydrology. Okay, let's see the answer. Definition. Hydro comes from the Greek word for water, and hydrology is the study of water, and hydrology are scientists who study water, okay? Any different aspects of water. And as a civil engineer, your works, some of your duties deal with water, either gathering, either transforming, either controlling, either regulating of rivers, dealing with floods, dealing with precipitation, distribution of water, and some kind of environmental issues, chemistry of water, and so many other things. What's the objective of hydrology is summarized here. And as a hydrologist, you apply scientific knowledge and mathematical principles to solve water-related problems in society. Problems of quantity, quality, and availability of the water. Okay, so to get warmer, to contribute in the course, Burak, please read this first paragraph to everyone.
Okay. Hydrology is aptly scientific knowledge and mathematical principles to solve water-related problems in society. Problems of quality and availability. They may be concerned with finding water supply for cities or irrigated farms.
Irrigated farms. Okay.
Irrigated farms.
Just stop. Thank you. Thank you. So stop 1 minute. You know, in this course, you will find so many new terms, new vocabularies that you don't know, because the course is really specific course. And I really encourage you to take a note if you don't know any new word, and go to the dictionary to find the meaning. Irrigated farms means farms that we irrigated with water in order to culture Irrigation means in Turkey. What is the mean? What does it mean, Ceren, in Turkey?
Tarımsal sulama diyebiliriz.
Yeah, this is Turkish
Or the
translation.
aim of
Okay.
agriculture.
Irrigated farms or controlling river flooding. Continue, Burak, please.
Or controlling river flooding or soil
Flooding.
erosion,
Flooding.
flying or soil erosion, or they may work in environmental production, preventing or cleaning up pooling or location
Pollution or location sites for safe disposal of hazardous waste. Okay, for the Ceren, please continue second paragraph you.
Okay. Persons trained in hydrology may have a wide variety of job titles. Scientists and engineers in hydrology may be involved in both field investigations and office work. In the field, they may collect basic data, oversee testing of water quality, direct field crews, and work with equipment. Many jobs require travel, some abroad. A hydrologist may spend considerable time doing fieldwork in remote and rugged terrain. In the office, hydrologists do many things such as interpreting hydrologic data and performing analysis for determining possible water supplies. Much of their work relies on computers or
Relies
on computers for organizing, summarizing, and analyzing masses of data, and for modeling studies such as the prediction of flooding and the consequences of reservoir releases, or the effect of leaking underground oil storage tanks. The work of hydrologists is as varied as the uses of water and may range from planning multi-million-dollar interstate water projects to advising homeowners about backyard drainage problems.
Great. Here you see that the author summarized some potential ways for or projects that a hydrologist can do. Now I want to ask you to give me some real projects that a hydrologist designed or worked in your country. Can you give me some famous projects relevant to hydrology? Any project relevant to water is a hydrologic project. The author said the diversity of works is the same with the diversity of water-related things. Okay, so Yunus Emre Özdemir, can you give me a project about hydrology in your country or in your hometown, especially in your hometown, I mean?
I don't know any of my hometown, but in Turkey we have Atatürk Dam. It's about water, so I think it can be an example. Yeah,
Atatürk Dam construction, a piece of great Anatolian project, GAP project. The GAP entirely is a project of hydrology, and I think the biggest project of your country is GAP. And look, the basics of this project, every basics comes from hydrology. The head of the project maybe is the minister, but the scientific head is a hydrologist. Because what the aim of project is, the aim of GAP project, you mentioned Atatürk project, Atatürk Dam, and maybe currently İlisu Dam. In that project are discussing between the scientists and also politicians because of its environmental impact and also its benefits to the country. At the end of this introduction to works, you see it's a multi-million dollars. There is no project more expensive than hydrological projects. Maybe the recent project that human want to move and enjoy traveling to moon could be expensive. But really, in the construction industry, there is no project more expensive than hydrological project. Building a tower, you can build a tower. Maybe it's less than 1% of the GAP project. In GAP project, as far as I remember, maybe it is not the correct, but more than tens of dams, kilometers of irrigation canals, several hydropower plants, several barrages, growing areas for agriculture, and so many construction works done in this project. Okay, GAP project is some example, but small scale examples we have also. A small example. Construction, for example, controlling river flood. In Antalya, we have what project? In Antalya, Boğaçay River. You see, today's 3 years ago, they started to change the estuary of the river. The point that river Boğaçay releases to the Mediterranean Sea. They made some pool there to do some activities. Entire process is hydrological process. Construction of some dikes, construction of flood walls, how they control sediments comes from the river. Now, after construction, there are still some works. How to diminish the negative impacts on environment. How to control the growth of some change, let's say change in ecosystem of the estuary. There is some change. And some scientists says these days that by making that pool, what we did, we stopped coming sediment to release to the sea. What will happen? The coastal or the beach of Mediterranean Sea decrease, the size of beach decreases because there is no input for sediment input to the sea. Is it understandable to you? So these are all topics that hydrologists should think and solve them. So let's continue with the mother or basic fundamentals of hydrology, which is hydrologic cycle. You know hydrologic cycle from your primary school. Here I will review to you different component of hydrological cycle, and you have an activity which I already uploaded on LMS. First, I'm talking about your activity, then I will explain hydrologic cycle component. Your activity is to go to the video lecture, or this is not lecture, actually a video, to watch that video which I put the link on LMS. Then you listen and write every sentence line by line. You should write it. When you listen, maybe video is 10 minutes. You will find tens of new words. You should know all of the words because repeatedly, frequently, I will use those words. Some of them you will see here, maybe, for example, transpiration or condensation. These are some new vocabs. Or runoff, you can't know it, or infiltration, but you will learn it during this course. So this is your activity, and then you should submit your handwritings to LMS system by the end of by the next week, or by the deadline I provided on LMS system. So please do it during this week, but let's go about, talk about the hydrologic cycle. Hydrologic cycle is the cycle or is the motion of water on the earth. Hydrologic cycle is a symbol from conservation of mass. Our mass here is water. You know from physics that mass, you know about conservation of mass. Mass never destroyed or produced, or the amount of mass is constant. I will talk more about conservation of mass in the next lecture today, but the basics hydrologic cycle says that the amount of water is constant, but it transfers from different locations to different locations, and it can have different phases. Not only it moves, but also it changes its form or phase from solid to water, from water to water vapor, gas, and all these is called hydrologic cycle. The engine for hydrologic cycle, or the force that is the behind this cycle is sun or solar energy. The first engine is sun, solar energy, and also gravity force. We have gravity force. That these two force allows we have this hydrologic cycle. You know that we have water bodies like oceans. You see oceans, sea, lakes, glaciers, or ice packs. These are all water bodies. And also we have atmospheric water, water vapor. We have water bodies below the ground. You see, we say groundwater, aquifers. Aquifers are groundwater. And all the water molecules, or in general, water moves between different water bodies at different times, but the amount of water remains constant at long term. Maybe you see that, yeah, there is less water in a dam these 2 years, but that water definitely and certainly is another location of the Earth or of the global hydrologic cycle. So what are the components of this cycle? There are different components, and the precipitation, as you see, is, let's start with precipitation. When we have precipitation, before going to precipitation, let's introduce you a new concept. Assume this part or section of the world is a part or a segment, what you can say, I want to say control volume, is a section that you control, it is your control volume, and you are going to study that part, okay? I will talk about control volume also more. So in this control volume, so you see different arrows at different directions. Some of them are downward, some are upward, yeah? In general, you can assume a control volume with some water, for example. All of those arrows shows where moves water. Some water can come into the system, into the control volume. Some water can go out to the control volume. For example, now, what? Anyway, assume the ocean, this ocean is your control volume. What is the input to the ocean? Can you guess? What is the input to your control volume? Jeren, please contribute.
The precipitation.
The precipitation. Ceren will start. What you please contribute also. What
here we can also see the runoff towards the
good.
Yes, one input.
Yeah. Two inputs we have. Two inputs, precipitation and runoff. I will talk more about them. So Zauerbeck Afralio, okay, what is the output for our control volume? What's the output of the ocean? He left the session. Okay, Selin, what is the output?
No, I'm not aware.
Yeah. You can continue. What is the output?
It's hard to answer.
Evaporation. Evaporation is output. Therefore, for this small control volume, input means precipitation and is runoff. The output is evaporation. However, this is only a part of our control volume. We have more and more bigger part, and there are, oh my God, different components. Now let's look at entire picture. There are several inputs and some outputs. The main input for this system is precipitation or rain. Precipitation, I will talk more, is the rainfall or snowfall is called precipitation. And when we have precipitation, this is the lecture display setting. You see correct screen, yes?
Yes.
When we have precipitation, some part of water can go exactly on oceans, some other can come onto the land. Some can precipitate on the mountains. Okay, based on different places that we have precipitation, different phenomena can be happen. Let's continue with definition of each word. Precipitation is the water or snow comes from clouds. We have evaporation, means water evaporated from the ocean, or evaporation can be from, you see, from the lakes. Evaporation also can be from land. Evaporation can be done from the land because we know that, for example, soil, this soil is wet, has moisture, and therefore water can be evaporated from the soil. This is evaporation. And when we have evaporation, what will be happen? Evaporated water, which is now in the form of gas, moves upward, and when it moves upward and goes to upper levels of atmosphere, what will be happen? We will have a decreasing temperature at upper atmosphere. By decreasing temperature, we will have condensation. Water vapors condensate and clear. After condensation, they create cloud. Water vapors create clouds. Then clouds maybe move up like here, and even you see we will have some evaporation. If the water is warm, if upper atmosphere levels is still not cool enough to condensation, the evaporation can be happen, and you can see such a dense or massive clouds. And at the the level, like here, let's continue, at the level that the atmosphere is cold enough, again, extra condensations creates raindrops. Or even if it is too cold, it creates snow flakes, and we will have precipitation process. So we know that now the condensation, we know the evaporation and precipitation. When we have precipitation on land or mountains like here, what will be happen? You know, some part of, we assume that we have precipitation on land. The dry land get moist, and we will have infiltration. Like you see here, infiltration means that water penetrates into the soil, on the underground, like here. We will have infiltration. And when the surface soil gets saturated, extra rainfall or extra moisture on the land creates a runoff, I was saying to a sheet flow, which is called runoff. A teen flow from different locations is called runoff, and moves into that runoff can move either into the ocean or into the lake, into a canal, into a river, and so many other systems. Now, so we know the runoff and infiltration, but what will happen on the water below the ground, infiltrated water? What will happen on the infiltrated water? Cem, if you are in the class, Cem Ayber. Cem Ayberk, can you answer this question? What will be happen on infiltrated water? Cem is not in the class like some others.
He wrote on the chat, sir. He's in the class.
Don't write there, Cem. If you want to talk, talk. If you don't want, be silent. Mohammed Khalid. Mohammed Khalid.
Yes, sir.
What will be happen on the infiltrated water? I mean this water.
It will change the kind of it will change, but it will not coming to go to be nothing. He's just changed the type of it.
No, change the type.
Yeah.
The infiltrated water will move. Where it moves?
Underground.
It can be moved either downward,
yes,
or sideward. Okay. If it moves downward, you see it is called percolation. It means that the moisture at underground moves to reach to groundwater or aquifers. In that case, we say percolation. Percolation is the process of motion of infiltrated water in deep ground into groundwater level. And maybe you see here, for example, infiltration can be also moved sideward to reach a root system, tree root system, or infiltration can move from soil to the river, to the lake. So we have therefore infiltration and percolation process in underground. We have runoff, evaporation, evaporation and runoff and evaporation at the surface level. We have also transpiration. You know, a biotic system has also water. Trees human, animals, they have water in their body, and we also evaporate some water from bodies, our bodies, animals or plants. Evaporation process from plants is called transpiration, as you see here. Water available in the in leaves of trees, in stem of trees, evaporated by time, it is called transpiration. And it is also for the animals called transpiration. And in general, both evaporation and transpiration process is called evapotranspiration. Therefore, if I ask you what does the evapotranspiration means, you can explain in a way that evapotranspiration is the process of changing of water to water vapor from both water bodies like lakes, rivers, and plants, and also land from land. This is called entirely evapotranspiration. And in general, if human do not manipulate the system, that this water cycle that you see, water loss from the system is in the shape of evapotranspiration. Water loss means output of the system, from this control volume in the form of evapotranspiration. Therefore, main condensation is only changing of the phase, okay? Only changing of the phase, not output of the system, yeah? Output is not output from the groundwater. Output from the groundwater level is in terms of evaporation. So there are so many other components in water cycle that you can find in the next slide in this YouTube video, which is your activity also. Watch the video and write down its script and submit your handwritings on LMS by next week. A deadline already given. Studies and up to this part of the lecture, you have to study section 1 to 1.4 of the our textbook. Now I'm going to open this video, but let's but you don't have voice, yeah? Let me share the voice first. How I should do it? I'm going to disconnect sharing, then share with voice of my computer.